Assalamu alaikum. Today we are going to see a new topic, inverse Laplace transform. This is first part of this topic, inverse Laplace transform. In this video we are going to see general properties of inverse Laplace transform, that is formulas. Okay, so before starting this video, this is my YouTube channel Explore Maths with Abdul Azim Sir. Like, share, comment and subscribe to my channel. Now let us begin the topic. Inverse Laplace transform. So what is the definition? If Laplace f of t is equal to f of s, that is already we know that, then f of t is known as the inverse Laplace transform of f of s and is denoted by L power of minus 1, that is Laplace of inverse Laplace of f of s. Then thus f of t is equal to Laplace inverse of f of s. Here Laplace inverse, that is L power of minus 1, is known as the inverse Laplace transform operator. Okay, and is such that L into L inverse is equal to L inverse into L is equal to I. Okay, now let us see some formulas. So table of inverse Laplace transform. So inverse Laplace transform is, if you know Laplace transform, then it is easily memorize or understand. So this is f of s, Laplace of f of s, that is f of t. So here 1 by s, if a function is 1 by s, that is Laplace inverse 1. Reciprocal, that is Laplace inverse, you know, 1 by s, and e power of at Laplace 1 by s minus a. So all are inverse only. So if you remember or if you understand Laplace inverse, it is easily to find inverse Laplace transform. Okay, now let us see the formulas. So 1 by s, 1, f 1 by s minus a, so Laplace function is e power of at. If it is s minus a, e power of at. If 1 by s plus a, e power of minus at. 1 by s power of n, see here, this is 1 by s power of n, where n is equal to 1, 2, 3. So the formula is t power of n minus 1 by n minus 1 factorial. Similarly, if 1 by s power of n, where n equal to 0, t power of n minus 1 by gamma n. Next, 1 by s square plus a square, nothing but 1 by a sin at. S by s square plus a square cos at. 1 by s square minus a square, 1 by a sin at. Minus means sine or sine hyperbolic function. So s by s square minus a square cos at or cos hyperbolic function. Here you should have first keep in mind, note that inverse Laplace transform of f of s need not exist for all f of s. There are some functions where you don't have any inverse Laplace transform. Now next, general properties of inverse Laplace transform or so Laplace inverse of c1 f of s plus c2 g of s is equal to, so c1 constant outside Laplace of f of s plus c2 outside Laplace of g of s, that is c1 into f of t plus c2 g bar of t. Okay, now let us see formulas. So this is known as first shifting theorem, or sometime known as first translation theorem. What is this? if Laplace inverse of f of s is equal to f of t, then Laplace inverse of f of s minus a is equal to e power of at into f of t is equal to e power of at Laplace inverse of f of s. Okay, so this is the basic formula. Now let us see all formulas. Laplace inverse of 1 by s minus a power of n is equal to e power of at t power of n minus 1 by n minus 1 factorial. If it is s minus a, e power of at. If Laplace inverse of 1 by s plus a, so here plus at. If it is s minus a, e power of at. If it is s plus a, e power of minus at, t power of n minus 1 by n minus 1 factorial. Both are same. The difference is here s minus a, e power of at. Here s plus a, e power of minus at. Okay. Next, Laplace inverse of 1 by s minus a whole square plus b square. See here, first 1 by s square plus b square, e, so sin bt, and s minus a is there, so e power of at. So Laplace inverse of 1 by s minus a whole square plus b square, 1 by b, e power of at sin bt. And Laplace inverse of s minus a by s minus a whole square plus b square, it is nothing but e power of at cos bt. Okay. Next, Laplace inverse of s plus a by s plus a whole square plus b square, nothing but e power of minus at, since plus is there, e power of minus at cos bt. And Laplace inverse of s minus a by s minus a whole square minus b square, minus is there, e power of at, minus means cos bt. Okay. Next, Laplace inverse of 1 by s minus a whole square minus b square, 1 by b, e power of at sin bt, hyperbolic. Minus means hyperbolic. Same here, minus means hyperbolic. Next, Laplace inverse of 1 by s plus a whole square plus b square, 1 by b, e power of minus at sin bt. Okay, these are the general, these two are general formulas you must remember. Next, second shifting theorem. Okay, second shifting theorem. So Laplace inverse of e power of minus as f of s, nothing but f of t minus a if t greater than a, 0 if t less than a. Next, inverse Laplace of derivatives. So if n is equal to 1, then Laplace inverse means d by ds of f of s is equal to minus 1 power of t Laplace inverse of f of s. Or you can write Laplace inverse of f of s is equal to minus 1 by t Laplace inverse of d by ds f of s. Okay. Next topic, inverse Laplace transform of integrals. Okay. Next, if Laplace inverse of f of s is equal to f of t, then Laplace inverse of integration 0 to infinity f of s ds is equal to f of t by t. Okay. So if it is integration with Laplace inverse, this is f of t by t. Next, power multiplication of by power of s. So if already we know that Laplace inverse of f of s is equal to f of t and f of 0 is equal to 0, then this is our formula you should remember. Laplace inverse of s into f of s, since it is multiplication, that is nothing but f dash of t. F dash of t means d by dt of f of t. So this is for multiplication s power of 1. In general, what we will write, a Laplace inverse of s power of n f of s is equal to fn power of t, that is nth derivative d power of n by dt power of n f of t, provided, this is the main condition, provided f of 0 or f dash of 0 first time derivative, second time derivative, and f minus 1 of derivative is equal to 0. Next, division by power of s, division. So if already we know that Laplace inverse of f of s is equal to f of t, so Laplace inverse of f bar of s by s, f of s by s is equal to integration 0 to t f of u du. See, s power of 1 here, if it is a Laplace inverse of f of s by s square, then 2 times of integration 0 to t integration 0 to t f of u du. So what we will write, in general we will write as Laplace inverse of f of s by s power of n. So integration 0 to t up to n times of integration 0 to t f of t dt of n. Okay. Now here, see, these are the some formulas you must memorize. It will be used in for problems as well as basic entrance exams. So memorize these following formulas. Laplace inverse of 1 by s square plus a square whole square is equal to 1 by 2a cube sin at minus at into cos at. Laplace inverse of s by s square plus a square whole square, nothing but t by 2a into sin at. Laplace inverse of s by s square minus a square whole square is equal to t by 2a sin at, hyperbolic. Laplace inverse of s square by s square plus a square whole square is equal to 1 by 2a sin at plus at into cos at. Next, convolution theorem. So what is this? If Laplace f of t is equal to f of t, f of s, and Laplace g of t is equal to g of s, then Laplace f of t into g of t is equal to f of s into g of s, or Laplace inverse of f of s into g of s is equal to f of t into g of t. Okay. Now next topic, use of partial fraction to find inverse Laplace transform. So as we have knowledge, or in partial fraction video I have shown you the complete forms of partial fraction. So in general we know that there are 4 types of partial fraction. First, non-repeated linear factor, repeated linear factor, non-repeated irreducible factor, repeated irreducible factor. So first we will find the partial fraction, then we will solve inverse Laplace transform. So by finding inverse Laplace transform of each of these partial fraction, the solution of the problem f of t is equal to Laplace inverse of f of s is equal to Laplace inverse of g of s by h of s can be determined. So this conclude the formulas and first part of inverse Laplace transform. So before concluding this video, again I am telling, this is my YouTube channel Explore Maths with Abdul Azim sir. Like, share, comment and subscribe to my channel. That's all.